Yes, let me start.
Perfect.
Hello, yeah, my name is Young Seo from KBS R&D. Let me briefly introduce the current status of mobile data casing service and emergency alert system. So let's go into the current UH status. It's a phase 1. So I can see my cursor here. Okay, yes. Firstly, we started from the quality issues. So we started here at the UHD TV, and we also the interactivity for sensors and screen smart devices for the video. And now we are focused on from the TDMB to the hybrid mobile service. It's kind of our next phase of next generation TV. So a lot of IP convergence service with set-top box and IP gateway is tried with the smart devices and TVs altogether, which enables the kind of smart services. ESG and indoor reception was the issues. And we already launched a kind of broadcast and broadband services branded TV VA in our UHD service. It was not that successful anyway. It is based on the HBB TV, but now it much looks like a normal OTT service. It doesn't confine its contents to the channel where it comes from. Now we are going to the UHD next stage. First, mobile service. These days, people enjoy TV as before, but most of the time, they are indulged in mobile for their own contents. This is more common, yes, now for enjoying video. But the problem is that for mobile reception, we need kind of devices, but we don't have that yet. So for experimental services, there are the dongles like this. So every demos we're doing with this, but we are expecting smart devices and car navigation videos with 83.0 chipset embedded. In our R&D, we tried many transmission parameters for mobile and fixed services until now. For test purpose, we maybe 3 years ago, we did that. In our channel, we adapted 2 systems. For the mobile, 5.5 dB TOV, it's about 2.4 megabps. And altogether, for the UHD service with the TOV of 15.5. So we tried this kind of thing. But QoS is very important for mobile service. So we devised several kinds of handoff technology. This is an inter-network handoff between RF and broadband. The video sync is very important for seamless handoff operation. And the next one is that kind of we call the in-band handoff, like Netflix. We send several scales of videos all together, and it can switch it when the good signal, UH quality, and bad signal, bad SNR, and HD quality like this. But we are expecting car media system for our next-gen TV service. For example, you see it, a big wide screen, windshield screen, AR window screen, and that is what is that? Flying car, that kind of need maybe precise GPS service. And for the video experience system will be provided. So we can fill with terrestrial high quality video. And the most important mobile service targeted for car is TPAC. It's the transportation information. TPAC includes congested traffic information and public transportation information, etc. for the mobile devices. This is broadcasting service. That means that it can be optimized for the terrestrial network. KBS has started TPAC service since 2005 with TDMV. Our TPAC service has real-time and non-real-time data. For the real-time data, CTT, that means the congestion and travel time information, and RTM, road traffic message like that. It refreshes every or about 3 minutes. And for the non-real-time data, there is oil price information, gas station information, and safe driving information, point of interest, news, and weather information, that kind of thing provided. For example, I think that broadcasting TPAC has a really good advantage over the communication defect because we send every road traffic information at a time in every 3 minutes. That means that on a map, every road condition is displayed. It's very good advantages. And also, we have some kind of information about the branches. We have the alternative for the destination. We made a typical thing. Every the kind of substitute, we provide the traffic information. And also news and weather information, including EAS. This push service is very useful for the broadcast station and also for the drivers. And advanced TPEG, we will do the R&D with about that. So that includes a kind of advanced transfer information, including CITS and RTK, location-based service, and mobility service like that. So we are doing experiment here in Jeju, TP, with RAPA and many manufacturers. So next one is emergency alert system. So when big disaster comes, for example, we had a very big earthquake in 2016 and a big fire in 2019. At that time, the cell network was paralyzed. That means that even the messenger cannot work. And sometimes electricity black out. So we only can use the battery operated radio or smartphone or automobile. That's all. That's only disaster only terminal. And the evacuation to public facilities, so people need some kind of information. So in that case, terrestrial disaster broadcasting and the terrestrial mobile terminals and terrestrial public services, that all three is included in the terrestrial US disaster warning broadcasting. So we have made service scenarios for next-gen TV based on IP convergence services. TV can deliver EAS messages through terrestrial broadcast data and IBB type communication network. For example, this slide, in case of earthquake, for example, we can include the earthquake break time and the current influence time, the places, languages, and sound alarm or map information like that. And also, we can include some IBB information like this.
When disaster approaches, the broadcast gets busy. It automatically displays the disaster information that updates every minute on the bottom of the screen. Instead of the internet, you can use the remote control to check various disaster information like 24-hour disaster news reports and action plans for different types of emergencies. On the other hand, the ATSC 3.0 network can be implemented to quickly notify about emergencies from anywhere.
We developed some kind of terrestrial service and smart device services. And TPEG, we will include the EAS also here.
Service is beyond the simple news report that provides various public data services.
Yes. And also the government and broadcasting companies will also try the public EAS terminal pilot service. That means that with the terrestrial broadcasting signal, there's a special equipment that shows the public EAS. For example, so we send broadcasters and signals, and there's a special equipment. So on the signboard or public place like theater, they can receive the disaster information, or public transportation, this subway and bus. There's a screen and a monitor, and the hospitals or elderly people hear the sound alarm. And we made this kind of standard that we can go through all these kind of devices. So let me wrapping up for the future mobile broadcasting media. First, broadcasting and 5G convergence services. We will maximize service efficiency, and we combine together the broadcasting and broadband services. So all the receivers can receive the same data and apply various situations, and include disaster service reception and response. And convergence service models is a hybrid companion service dynamics like that. So we will expand service quality through active use of broadcast and multicast services. And the next one is the next generation TPEG service that is intelligent traffic information system that includes high quality graphic information and lane-based precise location information with precise GPS and convergence of every terrestrial video, FM, TDMV, and UHD, they will work together, kind of hierarchical traffic information will be provided. So advanced TPEC service through the universal terrestrial video. And the last one is the next generation EAS, that kind of intelligent disaster information warning services will expand the concept of disaster to the kind of building collapse or road construction like that. And this kind of application, we made a lot of scenarios. So public transportation and quick updates like that includes the emergency alert service based on location information also. And application of a terrestrial EA through whole terrestrial video together. So that is the establishment of a social safety network anytime and anywhere by reliable reception of emergency safety information. Yes, that's the end of my presentation. Thank you for your attention. Thanks, Josh.